Alright, exercise 4D part 2, looking at a worded type question. Let's jump straight into it. So we're going to use bearings with trigonometry. A ship travels due south for 5 kilometers, then on a true bearing of 120 degrees for 11 kilometers. We're going to be looking for two things. We're going to find how far east the ship is from its starting point, corrected 2 decimal places, and we're going to find how far south the ship is from its starting point. So obviously we need a starting point of some sort. So a starting point right here. So this is the starting point of our ship. And the ship travels due south 5 kilometers. So due south just means going south. This is for 5 kilometers. Okay, pretty straightforward so far. Then on a true bearing of 120 degrees for 11 kilometers. So it's going to go for 11 kilometers, but we need to figure out which direction is that. So this is a true bearing of 120 degrees. So remember, true bearing is due north, and we're going to go rotate around past 90 till we get to about there. So remember, true bearing is always measured from true north, measures at 120 degrees, and then from here it goes for 11 kilometers. So about there. And this right here is 11 kilometers. Alright, so now our ship has its ending point right here. Alright, so this is the best diagram that we can draw. Now there are a few things that we can also put within here. I'm going to put this as a different color. This point where it's after it's traveled 5 kilometers, we know that, make sure this is in green, we know that over here we've got this direction, and I'm actually going to make it, I'll probably make it a bit longer so at least gets past that point here. This here is our east point, okay, and we know that if it's traveling south and there's an east point here, this degree within here has to be 90. So this point here has to be 90 degrees, meaning that this middle point in here is a difference of 120 degrees and 90 degrees. So this point here is 30 degrees. That I do know for a fact. Okay, this is as much information as we can fill in, and this is all we need. We might draw or extend on this a little bit more, but we've got a starting point down south 5 kilometers, 120 degrees, and then another 11 kilometers from that 120 degrees true bearing. So we're going to find how far east the ship is from its starting point, corrected 2 decimal places. So if the starting point is here and our ending point is here, we're looking for what that length is from there to about there, so it lines up. Okay, well, this length that we're looking for is exactly this length here. Just kind of shift it down because I don't necessarily care about the south part. I care how east it is. And I'm going to draw one more line. It's a dotted line, so you can see the application of trigonometry, because we've got a right angle triangle here. So let's replicate this right angle triangle and fill out what we do know. So the first thing we know is that it's a 90 degree angle here. We have a degree of 30 and we have 11 kilometers. What we're looking for is this length for now, this length here. So this here is our x kilometers. And let's just put SOHCAHTOA up the top. So we know which trigonometric identity we need to use. So let's look for this x kilometers, because that's the length from there to there, because that from there to there is our starting point and how far east we are going to 2 decimal places. So what we're using is the hypotenuse and the adjacent. So A and H, the first one, for A anyways, we are using cos. So the cos of 30 degrees is equal to A, in this case x, over 11. To get our x, we're just simply doing 11 multiplied by cos 30 degrees. So calculators out, let's clear that. We're doing 11 times cos 30 degrees, and this is, remember, make sure we press our SD button if we get something like that. This to 2 decimal places is 9.53. So this is equal to 9.53 kilometers. Now remember, this is a worded question, so we're going to answer it in a worded format. So therefore, what was the initial question? How far east the ship is from the starting point? The ship is 9.53 kilometers east from its starting point. Nice and simple. Okay, so that's where the trigonometry part comes into play. The bearing part wasn't really that tricky. Now, keep in mind that you will get trickier questions within the exercise, okay? But to integrate both of them together, this is what it looks like. Now we're going to look at B, and B is asking for how far south the ship is from its starting point. So instead of working out from there to there, we're going to work out what this is down, and then another part down here. Well, we already know that whatever we have to find out for this part here, we have to add 5 onto it, because we know for a fact that it's traveled 5 kilometers south in the first place. What we're actually looking for is this distance that goes down here, which is actually this distance here. And hey, that's within our right angle triangle again as well. So if we were to copy, this thing is so laggy, oh my goodness, here we go. If we were to copy this out, again, right angle triangle, 11 kilometers, 30 degrees. But what we're looking for is here, let's call this y kilometers because we've already used x. We can fill out that this is again our hypotenuse and this is our opposite, so we're using sine, so patoa. So our sine of 30 degrees is equal to opposite y over 11, or in other words, y is equal to 11 times sine 30 degrees. Now, you'll notice that within the question, before I actually get the answer, with A it says corrected 2 decimal places, but with B it doesn't. It doesn't say corrected 2 decimal places. Now you can make the assumption that, hey, because the first question says 2 decimal places, this has to be 2 decimal places. Sine 30 degrees is equal to half. This is a trigonometric identity that in time, if you were to take the specialist maths and maths methods route next year, you will know that sine of 30 degrees is half, or be in the back of your head. Okay, and we're just doing what 11 times half is, which is 11 over 2 or 5.5. But just to make sure, if you want that, that clarity, let's just do 11 times the sine of 30 degrees. There you go, 11 over 2, which is 5.5. 5.5 kilometers. So the distance, because we just worked out what this little length is down here, this distance is equal to 5 plus 5.5, which is 10.5, because you've got to remember the other length that we've got to consider at the start, which is that starting point. over here as well. So we have to add that 5 onwards. So again, what a question. So therefore, the ship traveled 10.5 kilometers south from its starting point. Booyakasha! Alright, which questions do we need to tackle? Let's have a look. So, exercise 4D, trigonometric bearings. So split this up into 2 parts. Don't worry about the compass sheet that's here. This is a resource that I don't want to use, not because we're in remote teaching, but I just don't want to use in general. I forgot to take it out. So questions 1, 2, 3, just to start off, which is from part 1, and then part 2, 4, 5, 6, 7, and 11. You'll be working on the first part of 4D for today, and then the second part for the next day, or Monday and Tuesday respectively, depends on which order you watch these videos or which days you watch these videos. If you have any questions, you know where I am. Just shoot me a message on Microsoft Teams during our designated periods. Just also be aware that during remote teaching, I do get a lot of students asking me questions for additional help. And especially on Monday, Tuesdays, and Thursdays, I have 5 on teaching load days. So if I don't get back to you, please don't take it personally. It's just I've got a backlog of a lot of people asking for help within my other classes as well. Add the screaming toddler to that mix, and you've got the household that is the home residence. So please just bear that in mind when you are asking a question. I only check Teams throughout school hours as well, and I only check emails on the odd occasion after those school hours. So if you need desperate help for a question, send me an email. If I don't reply, it doesn't mean I haven't checked my emails. I do check my emails after hours. I just don't have the time to reply to it. So just be patient. It's getting quite turbulent and quite busy. Okay, so just please keep that in mind. Until then, exercise 4D, and I'll catch you in the next video for exercise 4E, applications in 3 dimensions, which will be in a couple of days. Till then,